Hello. We are going to go over the quiz right now. I'll try to make this quick so it's not too long because I know you guys are doing this after school hours. Let's get to it. And it'll look a little different than what you saw today because it's a PDF version of our test, but the questions are the same. So you should skip down here. This was question 1. It says when solving this quadratic system algebraically and eliminating the y value. So that y variable. That means you had to do elimination and you had to have the y variable be the thing that was going away. The next step in the elimination process is, okay, let's see what they did. So, first step is they just wrote out the question. The second step, the thing that changed was this second equation. You can tell that everything has multiplied by 2. And this makes sense that they multiplied by 2 because you have to have the same number of y's to be able to eliminate them. It's both 2y and 2y. So that's great. The next thing that they did was they rearranged this second equation. So they moved everything over from the right side of the equal sign to the left side of the equal sign. They did that by subtracting the 4x squared and then adding the 2. So they got everything on one side of the equation. Now, if this was you doing this, your goal is to eliminate these y values. So if I have negative 2y and positive 2y, and my goal is to eliminate them, meaning make them equal 0, then I would want to add these two equations because negative 2y plus 2y would leave me with 0 y's, which would eliminate the y's. So if we look at our answers, it says add the two equations. C would have been our answer. Awesome. Number 2. The resulting quadratic created with only integers means no fractions. The resulting quadratic created with only integers when substituting the first equation into y of the second equation. So you have to substitute the first equation into second equation. Okay, so first things first. Let's do that substitution. They're going to go ahead. They're going to take that first equation. They're going to say y equals 2x squared minus 2x plus 1, and they're going to substitute it into y of the second equation, which would have given them this long sequence right here. Would have given them 2x squared minus 2x plus 1 equals, and then 3 over 4 x squared minus 9 over 2x plus 19 over 4. Okay. We've done the substitution part. If we look at our answers, you can tell none of those match. It's not even close. The first thing I noticed is that none of my answers have fractions, which makes sense because the question said no fractions. It said only integers. So to get rid of these fractions, I have to look at what's on the bottom and find a number I could multiply by that would get rid of all those fractions. The answer is multiplying by 4. So if I went ahead and multiplied everything by 4, I would get the following. 4 times 2 is 8x squared, negative 8x plus 4 equals, that 4 and that 4 would cancel, so 3x squared. 4 times 9 would give me 36, divided by 2 would give me negative 18x. And then that 4 and that 4 would cancel to give me plus 19. Cool. Still, none of my answers persist. So if I look, the next thing I'm going to realize is that all of their answers equal 0, while all of my answers don't, right? My answers, 2 quadratics equal each other. So I need to make this quadratic equal 0. I'm also going to notice that all their a values are positive, which tells me that I need to move my quadratic so my a values are positive. So I'm going to do that by moving the right side to the left side. So I'm going to subtract 3x squared. I'm going to add 18x. And then I'm going to subtract 19. This gives me 5x squared plus 10x minus 15 equals 0. If I look, that's option C. Awesome. So the first 2 questions never asked us to actually solve, but what it did was it ensured that you knew how to eliminate and ensured you knew how to substitute. These are the types of questions you are going to see on the test because it forces you to do one or the other and show you know how to actually substitute and eliminate. All right, number 3. Probably one of the hardest questions on the test. So if you look at number 3, it says the cross-section of a tunnel is the shape of a parabola. The parabolic shape of the tunnel is given by this function. They gave me a function right here. What is the width of the tunnel to the nearest tenth of a meter at a height of y equal 47.25? Okay. If you look at the picture, they've given you the tunnel, which is this equation. And we've even drawn a little line right here. I'm going to extend this line just so it looks bigger like that. The reason they gave you that line was to demonstrate to you that that is a second equation. That second equation is at y equals 47.25 because they had asked you what was the width at a height of 47.25. To figure out the width of the tunnel, I would have to figure out that spot, and then figure out the distance between those 2 points. To find those 2 points, I'm going to graph these 2 equations into my calculator. The first one being y equals 47.25. The second equation being negative 1 over 7x squared plus 6x. To graph these things, you're going to throw them into your y equals, right? So I got 47.25, and I got y2 equals negative 1 divided by 7x squared plus 6x. And then I'm going to set a window. All right, setting this window. X minimum. This should be the horizontal distance of a tunnel. So the minimum horizontal distance of a tunnel you could have would be 0. The X max. The biggest width that this tunnel could ever be. The width is in meters. I'm just guessing here, right? I'm going to say that the widest that this tunnel could possibly be is, I don't know, let's try 20. That might not be wide enough. I might have to adjust. It's just kind of a guess. My Y minimum, again, would be the minimum height of a tunnel. That would be 0. And Y max would be the maximum height of a tunnel. They already told me from the diagram that it's bigger than 47.25. So this is going to be a pretty big tunnel. I'm going to say the max is 60. And we're just going to give that a shot and graph it and see what happens. When I graph it, I can see my horizontal line nicely. I can't see my quadratic well enough. I just see the very start of it. So I need to see way further right. So I'm going to make my X max a much bigger number. I'm going to make it 50 instead of 20. So I go back, I change my X maximum to be 50. And now I can see my parabola and I can see my 2 intersection points. I can't see the highest point, so I would probably, if I wanted to see the maximum, go back and change my Y max, but I don't really care about that. So I'm just going to go ahead and find these 2 spots. To find these 2 spots in your calculator, you hit second, trace, and then intersect. When you do that, it brings you up. It says first curve, you move your cursor over to the first intersection. You hit enter, enter, enter 3 times. And it tells you that this first spot has a width of 10.5. When I go second trace, intersect again, and I move my cursor to the next intersection point and I hit enter, 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 it'll tell me that the X value at the second spot is 31.5. If I want to figure out the width of the tunnel at that height, I need to figure out the distance from 10.5 to 20.5. 31.5 minus 10.5 gives me 21 meters. So the width of that tunnel would be 21. Awesome. That's a hard question. Usually when we give this test and that question doesn't go well, it's a little hard to realize what it is they're asking you to do. All right, number 4. My Mean Girls question, right? These questions are from Mean Girls. We love Mean Girls. Best movie ever. Haven't watched it? Watch it. You're quarantined. What else are you gonna do? You're stuck in quarantine for like next week. Throw on Mean Girls. Like, come on. It'll be the worst hour and a half. I mean, best hour and a half of your life. You'll be happy. So watch the Mean Girls. Anyways, this question. Remember, when we get these questions, we want to build them as we read them. So one sentence will create one equation. Second sentence will create a second equation. So let's start with the first one. So those two numbers are related just as they're related. The sum. Sum means addition. The sum of twice the first number. Okay, I don't know what the first number is, so I'm going to say twice, which is 2 times x. The sum of twice the first number and the square of the second number. Okay, so that would be the second number, which is y, and squared. Is means equals 9. There's our first equation. 2x plus y squared equals 9. Reading the second equation, it says twice the difference between the first number and the second number is 15. So twice is 2 times. The difference between, so I have a difference, the first number and the second number, x and y. That would be twice the difference between the first number and the second number. That one's tricky, right? Because we got to have brackets around that. Is 15 means equals 15. If we look, that matches up with B. 2x plus y squared equals 9. 2 times x minus y equals 15. I love those questions. You're probably going to get another one because Mean Girls. I know, none of you are laughing at my joke again, and I'm fine with that. But, I'm not one to give up. Keep making the same joke until at least somebody laughs. So watch Mean Girls. Numeric response number 1. A baseball is thrown upward at an initial speed of 9.5 meters per second. The approximate height of the ball after t seconds is given by the equation, so they give you an equation. At the same time, a golf ball is hit upwards at an initial speed of 12. The approximate height of the ball, h meters after t seconds, is given by the equation, and then they give it. Okay, so we've got two people. They're throwing a baseball, and they're hitting a golf ball. I don't know anybody who plays baseball in this class. That's probably just me not remembering anything. So we'll say I'm throwing a baseball. When I throw the baseball, it's going to go like this, and land. And then we got Logan. Logan's going to be golfing, so he hits his golf ball. It starts at the same spot, and then it goes up and then down, and it lands. I just showed that I outthrow a baseball compared to Logan. So Logan hitting a golf ball. So I mean, Logan, maybe you gotta step up your golf game a little bit. That's all I'm saying. Anyways, we should have 2 quadratics, right? And I don't know what they look like. I don't know when they land. I don't know any of that, but I do know I have 2 quadratics. So they should cross each other somewhere at some point. I mean, that's what this unit's all about, right? So let's do that. Let's graph those 2 things because look at those numbers. They're absolutely terrible, right? When you get 2 terrible equations like that, it's a sign you need to graph it. You throw both into your y equals. The first one is negative 4.9x squared plus 9.5x plus 1. The second equation, we got negative 4.9x squared. And then we got plus 12x. And then nothing else. Oh boy. There we go. Okay. This is not working out at all for me on my calculator. There we go. Now, setting the window. That's going to be the important part. So we go to our window and we get x minimum. X in this question is how long these balls were in the air, right? Because look at our x values. It was t. T is time. They told me that somewhere. T seconds. Perfect. So the minimum amount of time that you could have would be 0. So x minimum should be 0. X maximum, the most amount of time this ball should be in the air. So if you're thinking you watch somebody golf and they hit a drive, that ball goes up in the air. If it's in the air for, I don't know, 10 seconds, maybe 20 seconds. That's a legitimate length amount of time. So I'm going to say 10 seconds as my X maximum. It might be wrong, but it should be close enough that I can at least see what's going on. Y minimum. My Y minimum is going to be 0 because that's the least amount of height that my ball could have. And if it's me hitting a golf ball, then that's probably the only height it has. The maximum amount of height would be my Y maximum. Again, you're going to have to go a little bit off of knowledge that they've given you. They've told you that height is in meters. So you're just going to guess a height of a ball in meters. I think if a ball went, let's say how H.J. Cody is probably like 10 meters tall. So if you're hitting a golf ball, you could probably hit it like 20 meters in the air. So let's say Y maximum is 20. That might be completely wrong, and I might not see enough. And I can always fix my graph afterwards. When I graph it, I end up having very little quadratics. My graph looks like this with that window. It's like whoop, whoop, like that. And that's not very good. So what we want to do is we want to go and we want to change our maximum values. I have too high of maximum values. So I'm going to downsize my X maximum drastically. I'm going to change this down to like 4. So that's my X maximum. And my Y maximum was also way too much. I'm going to down it to like 10. And when I graph it, now it fills the page a little bit better. And I have this quadratic right here. I've got one that goes up like this. And I've got another one that goes up like this. The question asks you, when are both balls at the same height? This moment right there is when they're at the same height. Again, you go second, trace, intersect. That's the 5th option. You hit enter 3 times, and it tells you that moment happens at 0.4, 4.016. Remember that the first value is time, and the second value is height. It said when. When is time? It happened at 0.4 seconds. Wonderful. Number 2. It says a linear quadratic system intersects at 2 locations. Algebraically determine the x-coordinate of the intersection. The x-coordinate of the intersection points can be written in the form a plus or minus root b. This tells me right here that I'm going to have to use the quadratic formula at some point, right? Look at that answer. Not pretty. So I need to solve this algebraically. If you tried to do it with your graphing calculator, you would get decimals, and decimals don't look like this, so it's not going to work out. Another one of our tricks to make you do algebra. So you have 2 options. You can either substitute or you can use elimination. I'm going to substitute. I'm going to take this right here. I'm going to substitute it into that y value so that I now have 2x plus 1 equals x squared minus 2x plus 3. I'm going to move everything to the right. So I have x squared minus 4x and then plus 2. I'm going to have to do the quadratic formula because I can't factor that. The quadratic formula is negative b. My b value is negative 4 here. Plus or minus the square root of b squared. Remember to put your values in brackets. Minus 4 times a, which is 1, times c, which is 2. Divided by 2a, which is 2 times 1. You do a little bit of calculating. This becomes 4 plus or minus the square root of, that'd be 16 minus 8, which is 8, divided by 2. Sometimes people get stuck there. Remember that you have to simplify that radical. So that square root of 8 would become 2 root 2. So I have 4 plus or minus 2 root 2 divided by 2. I then realize that all my coefficients can divide by 2, giving me an answer of 2 plus or minus root 2. It says place the value of a, this is a, in the first box, b, this is b in the second box. My answer should have been 22. Tricky. I ripped through that algebra, so you might want to pause that and look back just to see, maybe even just pause as I'm going so that you can see what I'm doing as I go from step to step. Awesome. Numeric response number 3. In a linear system, how many scenarios may arise when determining the number of solutions? Linear system. How many different possibilities are there? Okay. Well, in a linear system, I could have one line, creating one intersection right there. That's one scenario. Another scenario I could have one line and a parallel line like that. That would be no solutions. Second or third scenario I could have one line and another line right on top of it. That would be infinite solutions. So the number of possibilities that could arise, the number of scenarios that could arise from a linear system, there's 3 scenarios that could arise. I could have got 0 solutions, 1 solution, or infinite. Perfect. The second part, a linear quadratic. Okay, a linear quadratic. You could have, there's your quadratic. You'd have a line that doesn't touch at all, a line that touches perfectly once, or a line that touches 2 times, giving you 3 scenarios. You could have 0 solution, 1 perfect solution, or 2 intersections, 2 solutions. And finally, a quadratic. Quadratic could have this, 1, 2, where they never touch. Second scenario, you could have 1 quadratic, second quadratic where they touch just 1 time. Third way, you have 1 quadratic, you could have a second quadratic and they touch twice. Fourth scenario, you could have a quadratic and another quadratic right on top of it for infinite solutions. That means there's 4 different possibilities: 0 solutions, 1 solution, 2 solutions, or infinite solutions. Awesome. Number 4. We're not going to have one like that on the test, so I don't want you spending too much time studying it. Normally, I would give you one like that on your test as well, because I do like those types of questions, and they are very beneficial, but they're very time-consuming, and I know they're also very frustrating. So I actually took it off of your test for tomorrow. I mean, hey, you can thank me later. So don't worry about studying it. Yeah. Okay. The next part. The next part is doing our sequences and series, so the stuff we just learned during this online world. The first one says a doctor prescribes medication to be taken for 9 days. The amount taken on the first day is 270 milligrams. For each successive day, that means that every day after that, the patient is to take 1/2 of the amount taken on the previous day. What is the total amount of medication prescribed to the patient? Okay, so if we think about this, that means I have 270 milligrams on day 1. On day 2, I am to take 1/2. That means this would drop down to 135. On day 3, this would drop down again to 1/2. Half of that would be 67.5, and so on and so forth. They're asking, what is the total amount of medication prescribed to the patient? That would be if you took all the medicine for each day and added it up. This would be a sum question, and it would be the sum of 9 days. You then have to pick a formula. So if you look up here at your formula sheet, you're looking at the S of n's, which is these options right here. And you're also looking for an S of n that has the letter R in it. The reason I'm looking for one with the letter R is because R is your ratio. It's for questions where you're doing multiplication or division. This was a division question because I was taking 1/2 of my medicine every next day. So I was dividing my medication by 2. The next thing I want to decide is which one of these formulas with R do I want to pick. So I'm not going to pick one of these two because they don't have the letter R. To decide between the two equations, look to see what you have. So this equation, all I need to know is the first day, my ratio, and how many total terms there's going to be. For the other formula, I need to know R. I need to know the amount or the term on the nth day, the last day, and I need to know T of 1. I don't know the term on the last day, but I do know how many days there are. So this is the formula that I'm going to want to do. I'm going to want to do S of n equals T of 1, R to the power of n minus 1, and then R minus 1. So if I go ahead and I try plugging that formula in, I get S of 9 equals, I believe the formula was T of 1, R to the power of n minus 1, R minus 1. Let's plug this in. S of 9, we still don't know. T of 1 is medicine on the first day. That's 270. R is half, which is 0.5. N is there's 9 days total of medicine. Minus 1 divided by R minus 1, which is 0.5 minus 1. If you throw this whole thing in your calculator, which I'm going to do right now, I go 270 bracket 0.5 to the power of 9 minus 1 divided by 0.5 minus 1. And I get, well, that's not right. Let me try that again. I typed the wrong thing. I put a plus sign instead of a minus sign. Try it again. I get S of 9 equals 538.9. If you want to prescribe this medicine, if you did 300 or 538, it wouldn't be enough medicine. You would rather have a little extra, unless you're ODing on the patient. Maybe that's a bad idea. No, we would just round this thing properly. So this thing would round to be 539 milligrams. Awesome. Number 6. The population of a city was 173,500 on January 1st, 1978. On January 1st, 1992, that same city had a new population of 294,000. Determine the average annual growth rate, so I'm looking for R, of the population during that time. Express your answer to the nearest tenth of a percentage. Okay, so they gave me the population at the start. That's going to be my T of 1. Then they gave me the population somewhere else. So they said T of 1 equals 294. Oh, sorry. 173. 500. Then they gave me another population. That population was how many years later? So if you go from 1992 and you subtract 1978, that would tell you it was 14 years later. So that means this new population is T of 14, which is 294,000. Then they're asking me to find R. Okay, I know some information here. I have T of 1, T of 14, and R. I look up my formula sheet. I'm trying to find R, so I need to pick a formula that has R in it. I also know T of n. I know T of 1. And technically I know n, it was 14 years. So this is the formula I'm going to want to pick. So I go down to my formula, and I start filling that in. The formula was T of n equals T of 1, and then R to the power n minus 1. That means I have T of 14 is 294,000 equals 173,500 times R, which we don't know, to the power of N, which is 14 minus 1. To solve this is a little tricky. So you have to divide both sides by 173,500. And then you have to do something that's a little unique. So we're going to 294,000 divided by 173,500. They get 1.6945. And then some more numbers. Equals R to the power of 14 minus 1 is 13. Now I have to get rid of that exponent, that 13. To do that, I would have to take the 13th root. To do the 13th root in your calculator, you type in 13, then you hit math. And if you look at the fifth option, it's a little X with a root sign. That's the one you want, so the fifth option. That'll give me the 13th root. And then I want to do 1.6945, and I get 1.0414 equals my R. If I look, none of those answers match up. The reason none of them match up, sometimes people will pick A because they'll see 1.0 and they'll think that's right. That's actually not correct. When you're looking at a rate like this in a question, this 1 represents 100%. This 0.0414 equals your growth. So that's 100% of the population and then plus that growth. So my answer is actually 0.0414. If you change that into a percentage, it's 4.1%. It's kind of tricky, right? So when they're talking about growth rates of cities and whatever, stuff like that, the one in front represents that you have 100% and then plus a growth rate. Tricky, I know. If you had a number like this as your answer, like 0.94, the way you would figure out that rate of growth, the 0 tells me that it's going down. And then I have to figure out how much it's going down. In this case, to go from 100 to 94 would be subtract 6%. So this rate would be 6% going down, like depreciating or declining. So you can have growth rates and like shrinking rates, declining rates. You're getting smaller. That's tricky, I know. All right. We're almost there. Thank you for toughing this out with me. You're doing good. Okay, number 7. Given the series, and then they give you a series, which statement best describes this series? It is a converging series with a common ratio of negative 1.5. B, it's a diverging series with a common ratio of negative 2 over 3. C, it is a converging series with a common ratio of negative 2 over 3. And D, it's a diverging series with a common ratio of negative 1.5. Okay, let's start off with talking about 2 words. Converging, diverging. Converging. Converging things means it's headed to a number. So for instance, if I had numbers like 10, 9, 8.5, 8.25, 8.1, 8.05, 8.004, you could see that I'm headed towards the number 8. See, I'm converging towards 8. I'm getting really, really close to 8. I'm not quite there, but I'm getting close to 8. That's called converging towards a number. Diverging means you're going away from any numbers. You're not actually headed towards anything. You're not headed to anywhere specific. So, for instance, if I give you a sequence like 10, 15, 27, 39, 59, 75. I mean, my numbers are getting bigger, but I can't tell where it's going to stop, right? Like it just seems to be going off into forever, into infinity almost. When you see something like that, that's called diverging. So if you look at this equation, it's definitely diverging. It's headed off into infinity. It's not getting close to anything. It just keeps going. So it's not A and it's not C because it's a diverging series. The next thing is figuring out the common ratio. Common ratios are they're hard to find. They're not always just obvious, right? So to find your common ratio, what you want to do is you want to take one of the numbers in your series. Let's take -3, and you want to divide it by whatever's in front of it. So in this case, if you did -3 divided by 2, it would tell you that the rate that you're decreasing or increasing is -1.5. So my ratio is -1.5. That means I'm a diverging series with a ratio of -1.5. I am D. Cool. Number 8, given the arithmetic series, t of 2 equals this, t of 8 equals this, determine the value of t of 30. When they give you two terms and neither one of them is the first term, you need to go and reorder your terms. So I'm going to change this. Instead of t of 2, I'm going to make it t of 1. That way it actually fits into my formulas. To get to t of 1, I had to subtract 2 by 1. So that means this is no longer t of 8. This is now t of 7. I have to take it back one term. And instead of looking for t of 30, I'm now looking for t of 29. Right? I had to go reorder all of those things. The next thing is I can't figure out t of 29, this random term, unless I know what the difference is. And I don't know what the difference is in this arithmetic series because they never told me. They just gave me t of 1 and t of 7. So I need to use a formula to find my difference to be able to do anything here. When I look up here at my formula sheet, this formula right here could be used to find my difference because I know my 7th term, so I know a random term. I know my first term now. I also know the number that my random term is. It's 7. And then the only thing left is D. So I'm going to use that formula to find my value of D. So my formula is t of n equals t of 1 plus n minus 1 d. When we plug things in, this is going to be t of 7 equals t of 1 plus n minus 1 d. So let's start plugging things in. T of 7 is 38 equals 5 plus 7 minus 1 and then d. That value 7 is because we're talking about the 7th term, right? Those two numbers have to equal each other. I'm going to subtract the 5 to the other side. That gives me 33 equals 6d. I divide both sides by 6. Whoa. When I divide both sides by 6, I get 5.5 is my difference. Now that I know my D value, I could find any term I want. This question specifically is asking me for the 29th term, so I could go T of 29 equals T of 1 plus N is 29 minus 1 times my D value, which is 5.5. So I can use that formula now again, but with different values find the answer. You throw that into your calculator, that's going to be 159. And I always like when my answer is somewhere on the sheet, because then I can check it off. The answer is B. Awesome. Number 16. James determines that the sum of the first n terms of a geometric series is simplified to be s of n equals 5 to the power of n minus 1. For this series, James makes the following statements. The common ratio is 5. The first three terms are 4, 20, and 100. The difference between the common ratio and the first term is 1. The difference between s of 6 S of 5 is the same difference between S of 4 and S of 3. Determine which statements are true. Put a 1 for true, 2 for false. Okay. First off, what the heck formula is he using, right? So it looks like he's using the sum S of n. So we look up, let's see if we can figure out which S of n he's using. So if I'm guessing, I'm like, what S of n is he up to? I'm going to assume he's not using this one or this one or this one. And my assumption comes from the fact that his answer has exponents in it, right? And the other answers didn't. So I'm going to assume that because his answer had exponents in it, this is the only sum series that had an exponent. So I'm going to go ahead and see if I can somehow figure out how he turned this thing into what he has. So I'm going to go down there. And let's see what he did. So my formula with an exponent was S of n equals T of 1 R n minus 1 and R minus 1. Somehow he took that formula and turned it into this thing. And I know that when you did this question, you probably hated me. And that's okay. I can handle it. The hate is momentary. I know it's not a personal thing. Because you're probably like, what is going on? How did he figure that out? So if you look, he's got this 5 to the power of n minus 1. That looks an awful lot like that. Right? Like that looks like those two things must match up. So that means that somehow these things canceled out. So somehow that T of 1 and that R minus 1 canceled out, so all I was left with was the blue part. If we're assuming that these two blue parts match up, then it also means I can assume this 5 must be R. So that means he must have had this. S of n equals T of 1 5n minus 1 divided by 5 minus 1. This also means that now I can figure out what T of 1 was because it must have canceled out with that 5 minus 1. So he must have had S of n equals 4 5n minus 1 divided by 4, because 5 minus 1 is 4. These things would have canceled, and that's how he got this formula. That is hard. Like, that is high-level hard thinking. If you got that, awesome. If you didn't get it, I'm sorry for all the frustration that I caused you. I didn't mean to do it on purpose. Blame Miss Schaub. Okay. But this tells me a lot. So this means the only way he got that was by figuring out a few things. First thing is he figured out that R equaled 5. The second thing he figured out was that T of 1 must have been 4, because that's the only way that canceling would have happened. So now I can go ahead and start looking at what he's got here. He's got the common ratio is 5. That is a true statement. So that'd be a number 1. The first three terms are 4, 5, and 100. That ends up being true. We know the first term is 4. We know the ratio is 5. So that means if you multiply by 5, you should get those things. 4 times 5 is 20. 20 times 5 is 100. The first three terms are 4, 20, and 100. Number 3, the difference between the common ratio and the first term is 1. That is true because the first term was 5 and the ratio was 4. So the difference between these two numbers would have been 1. That is true. And the last one, the difference between S of 6 and S of 5 is the same difference between S of 4 and S of 3. That's highly unlikely, but we're just going to prove it anyway. If we keep going, the fourth term times it by ratio 5 would be 500. Times it by 5 again would be 2,500. The difference between the fifth term and the sixth term, oh gosh, I have to times by 5 again. So times by 5 again, I would get 12,500. The difference between the sixth and the fifth is 10,000. The difference between the fourth and the third is 400. That is definitely false. Just for the record, it's very rare for the difference to be the same when you're doing ratios. Ratios is multiplying, right? So the difference shouldn't be the same every time. That was true, 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 false. Last one. If you've lasted this long through the video, well done. This one, number 6. How many terms are in the sequence? How many terms means you're looking for n. If you look, then they then give me a bunch of information. They give me the first term. Then they give me the second term, the third term, and then they give me the last term, which I don't know. I'm just going to call it T of n. I then also have to figure out how these numbers are changing. They're actually changing by a ratio. I know they're changing by a ratio because if you tried adding from this one to this one, it's different than the addition from this one to this one. It's not the same adding. So this means I have to have a ratio. The way I take a ratio is I take one answer, 0.021, and I divide it by whatever is in front of it, 0.007, and that will give me my R value. I believe it's going to be 3. Let me just make sure. 0.021 divided by 0.007. I know that R equals 3. So now I know T of 1 equals 0.007. I know T of n equals 413.343. And I know R equals 3. I then have to have a formula that has those things. If I look up to the top, this formula has all those things. It has T of n, T of 1, R, and n. So that is the formula I want to do. If I go down here, that means I'm using the formula T of n equals T of 1 times R to the power n minus 1. And then I can start to put in information. So T of n was 413.343. That's the last term. T of 1 is 0.007. R is 3. N we don't know. You're going to have to divide 0.007 to the other side. If you do that, 413.343 divided by 0.007, that gives me 59049 equals 3 to the power n minus 1. Then to figure that out, it's going to sound terrible, but you're going to have to guess and check a few things. So in your calculator, you're going to go ahead and just start trying things. You're going to go 3, and you're going to go to the power of something. Let's go 3 to the power of 20. Whoa, it's way too big. If I try 3 to the power of 20, I get a massive number. 3, 4, 8, 6, 7, 8, 4, 4, 0, 1. My goal is to equal this. I'm not even close. So I'm going to try 3 to the power of 10. If I go 3 to the power of 10, Oh, look at that. That's a good guess. I get 59049, which matches. That matches that. This means that n minus 1 must turn into 10. The only way that could happen is if n was 11. Therefore, there's 11 terms in that sequence. Wicked. Tomorrow's test will include sequences and series and systems of equations. It'll be very similar to this test. Study this one a little bit more. Take your time. Email me questions if you need it. I'm planning to do my best to answer emails tomorrow night, or I'm recording this the night before. I'm planning my best to answer your emails tonight so that you are ready for tomorrow morning. Take care of yourselves. Take a study break, maybe like an hour and 40-minute study break tonight. Mean Girls is about that long, I think. So if you're looking for something to do, you could do that. Or, just study all night and drive yourself crazy. Whatever makes you feel better. All right, take care. I'll see you soon.